Sometimes just one function is not enough to describe certain real-world situations. In the real world, for some parts of a domain, one function might apply, and for other parts of the domain, another function might apply. We call this a piecewise function. Different functions put together in one, and parts of a domain will determine what type of function is happening at what part of the domain. A piecewise function may be continuous or discontinuous. So sometimes you might see gaps in the y values of the same function. An example of one is from negative infinity to 0, the f of x equals x squared, and this is not inclusive of 0. For 0 inclusive through infinity values of x, the f of x equals 3. What would this look like on a graph? Well, from all negative infinity forever down to just up until 0, not including 0, the function is equal to x squared. It's a parabola. And then, starting at 0, the function jumps to being a constant, 3. So you can see we have the first part of the function over here and the second part of the function going through infinity over there. Now, notice also we used an open circle to show that the end of the first function does not include the 0, and a closed circle to show that the beginning of the next function includes the 0 value as at 3. Let's look at an example of how we might interpret a piecewise function. Blair is identifying the functions that make up the piecewise function graphed below. What is the equation for the function when x equals -1? So just by looking at this, you can tell there is a function over here, but that is not the same function as the one going on from there on. So we want to see what is the function when x equals -1. Well, let's find -1 on the graph. There's -1, and at -1, we are looking at this function right here. So let's figure out what the equation for that function is. It's a linear function, so it's going to have something like y equals mx plus b as its equation. It has a b value, a y-intercept of -2, so we've got y equals x minus 2. That means it could be this function right here, this one right here. Those are our two options. It also has a downward slope or a negative slope that tells us it is most likely this function right over here, -x minus 2, since the slope is negative. One more thing to note, this function is a continuous function. There are no gaps in the y values. However, this example from when we were defining a piecewise function, that is a discontinuous function. There is a jump and a gap in that function.